All right, today we want to look at sort of something to help you do some debugging. So, and something called stack diagrams. So, as you can imagine, as you have longer and longer programs, those should be broken up into logical pieces, logical steps, and then each piece should be implemented with a function. That just makes the program easier to write, and it makes it easier to read, and easier to debug. That's why it's easier to write, because you can narrow down, like if you make an error somewhere, you can sort of go function by function kind of testing them. Well, does this one do what I think it should? Yes, this one is correct. Everything's good here. If you have a whole big long hundreds of lines of code, it's much harder to figure out where errors are if it's not broken down into pieces where you can kind of test them a piece at a time. Okay. But as you can imagine, if you get these large programs, it can be difficult to follow the flow of where things are going when you have lots of function calls. I mean, function calls are great because it breaks up the program and makes each smaller piece easier to read and digest, but then you're jumping around from piece to piece. This piece is calling this piece, and and start figuring out where it's going and what's calling what. Can be difficult. So imagine like when you have a function that calls a function that calls a function that calls it, you get an idea. It keeps going on, and you can keep composing these functions. So what can be helpful if you're trying to trace down errors or just figuring out what the program does is you can keep track of which variables are currently in use and what the values of the variables are and what the program is doing, basically, if you use something called a stack diagram. So in the stack diagram, you'll show the value for each variable and the function to which that variable belongs. And every function is represented by something called a frame, which is really just a box, and then the name of the function along with its variables, its local variables, and its parameters. Okay. And then one nice thing is that if an error occurs during a function call, Python will print the name of the function and the list of all the function calls that were made to get there, and that's called a traceback. So I'll show you that and how that corresponds to the stack diagram that we're going to draw. So we're going to look at a modification to our triangle program. Don't worry, I'm not going to use this triangle program though for every example all semester. It's just that we're already familiar with it, so it's nice to make us little small changes and see what's happening. Okay, so this is my new improved triangle program version 1.3. Here's the main program, so let's just look at what's happening down here. So I'm going to assign some values for the sides of a triangle. I'm just going to make it an equilateral triangle. I'm going to display my little greeting message. And now I've written a new function called triangle info. Okay, so I'm going to do triangle info, side 1, side 2, side 3, and then I'm going to scale up the triangle by a factor of 2. So I'm going to take each side and then multiply it by 2. So I'm going to double the side length, and then I'm going to call triangle info again. All right, so triangle info is a new function to us, so let's go up and look at what it does. So here I've defined triangle info. So triangle info is just going to print a blank line, so there's separation between the outputs so that it's easier to see. And then it's going to say triangle sides and tell us what the lengths of the sides are. So the 3 sides that got passed in, A, B, and C, those are the parameters. It'll print those out and then tell us what the perimeter and area are. Okay, so notice it'll do triangle info. It'll print all the sides, the perimeter and area. It'll change the side lengths and then print all the sides, the perimeter and area for that new triangle. So you can just print all the information about the current triangle that you're thinking about. Okay, so maybe we wrote this program because we're trying to figure out, well, if you scale up the sides by a factor of 2, how will that affect the area and how will that affect the perimeter? Will they both be doubled? Hopefully you know the answer to that question, but we'll go and look at it anyways. Okay, and so the perimeter and area function do just exactly the same thing that they did previously in our previous example, so nothing new about that. Okay, so let's say that we wanted to figure out what this program was doing. Okay, and so to draw a stack diagram, the way that things work is you have something called a stack. Now a stack is like if I take, let me move this over. Okay, and if I put something on top of something else, 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 I'm making a stack. Okay, and that's kind of how things work. So as you make function calls, it just stacks these functions, okay, and what's called a frame. Okay, so each of these functions goes frame by frame. So every time you make a new function call, a new frame is put on a stack, and whatever frame is on the top of the stack is the context in which we're working. So if we follow through a program, imagine we're in the interpreter. So what the interpreter does, okay, well, it always starts at the first line of the main program. Okay, and so it has, I'm going to turn this over so it's not a distraction. So on our stack, it puts a frame for the main program. Okay, and it'll also keep track of all of its local variables. So there will be a variable for side 1, for side 2, and for side 3. Those are its local variables. Okay. And then it'll keep track of what the values are. So right now, side 1 was given a value of 2, side 2 is given a value of 2, side 3 was given a value of 2. Okay, so it does these, and then it comes to a call, display greeting. Okay, well, as soon as it sees display greeting, that's a function call. So when a function call is made, it puts on top of the stack a new frame. Okay, and so now we have this frame for greeting. Okay, so our display greeting, I should have put the whole name. Okay, so display greeting doesn't have any parameters. It doesn't have any local variables, so it'll just be the name. Okay, and then it does its thing. All right, it prints this, it prints this. Well, that's all there is to do. And as soon as it gets to the end, and it will exit the function either with a return or by just running out of things to do. And when it returns or exits the function, it'll take the top value and it'll take it off the stack. Okay, so where do we go back to? Well, we go back to here, back to main. And so it'll come back to, we've just left display greeting, so we're all done with this. Basically comes to the end of this statement and goes down here. All right, the next thing that the interpreter sees is a call to triangle info. So it'll create a new activation record is what it's called, so a new frame for triangle info. And then it'll say, all right, triangle info, side 1, what is that? Okay, well, it'll look at the call. So in triangle info, oh, sorry, these were called A, B, and C. Rats. So A, B, and C are the names of the variables in triangle info for their parameters. Okay, so it goes and it says, all right, well, side 1 had a value of 2. So that's going to get copied in for the first parameter here. So this will become 2. And then side 2 is in the second slot. Well, that's got a value of 2. Okay, so that will get copied into the second parameter, B. And then side 3 has a value of 2. That will get copied in for the third parameter. Okay, so now that's what our frame looks like. Okay, and so S, nothing else exists in this frame besides A, B, and C. So if I were trying to say, print, up here S1 and S2, those don't exist here. Now we did see last time that side 1, side 2, side 3 that are part of this main program could be accessible, but you don't really want to have other functions changing things in your main program. That'll just make things very, very confusing, because when you look in your main program, things start changing and your main program didn't change it. So you don't want other functions to do that. Okay, so we have A, B, and C. They each have a value of 2 in triangle info. And so we will print a blank line, print the statement triangle sides, and then we'll, for A, B, and C, it'll use these values that it has stored there in its frame, 2, 2, and 2. Okay, and then it'll say perimeter is, and now it's making a call to perimeter. And so when it makes a call to a perimeter, another frame gets put on top of the stack. Okay, and when we called it, the first variable there in perimeter is side 1. That gets a value of 2. Copied in from A in triangle info. Okay, and then B is a value of 2. That will get copied into side 2. And then C has a value of 2. That will get copied into side 3. Okay, so now we're in perimeter. So it's got parameters side 1, side 2, side 3, and the values of 2, 2, and 2 have gotten copied in. Okay, and so then we do this expression, side 1 plus side 2 plus side 3, which is 6, and we return the 6. Now when we return the 6, as soon as we see that return, this one is taken away from the top. Where do we go back to? We go back to wherever we left off in triangle info. That's at the top of our stack now. So we called triangle info, like we just left perimeter. That's the thing that went off the top of the stack. So we're going to go back to the end of this call. This has been called and it returned the number 6. So now it's going to put 6 here. So when this print is called, it'll pass perimeter is, and it'll print the value, and the value 6 will get passed to the print function, and it'll do perimeter is 6. All right, that one's done, and so it'll come down here and it'll do print, and I want to call print with, this is its first argument, and the second argument, O, is a call to area. Okay, so that's a function call, and so on the top of our stack goes a frame for area. Okay, now the values for A, B, and C are saved there, 2, 2, and 2. So those get copied in. Okay, and now we're in area, so we'll do S is 1/2 of, and then it calls perimeter. All right, so it's going to call perimeter, and the side lengths of 2, 2, and 2 are going to get passed in. So now we have perimeter. All right, so it's going to add up 2, 2, and 2, get 6. Sees the return. It'll take this off. This is returned a 6, so it'll do 1/2 times 6 is 3, and this will have a value of 3. And then it's going to do math dot square root. Okay, so it's going to have the square root of 3 times 3 minus 2, which is 1, times 3 minus 2, which is 1, times 3 minus 2, which is 1. So it'll have whatever the square root of 3 is. What that is, about 1732. Something like that. All right. And then it'll store that in A. And then it'll return A. Okay, as soon as it sees the return, this is going to pop off. Okay, and it's going to go back to triangle info. We just left area, so here it's going to print our 1.73 whatever. Okay, now as soon as this is done printing, okay, well that was the last line of triangle info. It's all done with triangle info. And so this one will come off. Okay, which means we've just returned from triangle info. We just have finished this. And now, next we come down here. Side 1 equals side 1 times 2. Okay, so first of all, it does this, side 1 times 2, which is 4. And then I'll save that for the variable side 1. So this is now 4. And then it goes down to this statement. All right, well, side 2 times 2 is, the current value of side 2 is 2. Multiply that by 2, you get 4. And I'll take that value of that expression and I'll save it for side 2. So this one becomes 4. And the same thing happens down here. All right, now I'm done with these three statements. I have new values for side 1, side 2, and side 3. Well, now I make a call to triangle info. Okay, well, triangle info, I create a new frame for triangle info, and the current values of side 1, side 2, and side 3, which are 4, 4, and 4, get copied in. So this becomes 4, this becomes 4, this becomes 4. All of the old information is lost, is gone. Okay, and so now we're in triangle info. It's going to print a blank line, and then it's going to print triangle sides, and then it's going to pass the values 4, 4, and 4 to the print statement, and it'll print those 4 sides. And then it'll say print. The first argument is perimeter is. The second argument will be a call to the perimeter. All right, so I create a new frame for perimeter. And the current values for A, B, and C, which are 4, 4, and 4, get copied in for the parameters. Okay, and so now I'm in the perimeter function. Okay, and I have the values of 4, 4, and 4 for side 1, 2, and 3. Add those up and I get 12. And then it says return 12. Where do I return it to? Well, when I take that off the top of the stack, I'm going to return it to triangle info. Okay, so I'm going to return it to this function, and it had just called perimeter, so there's going to be a 12 right here, and it'll print perimeter is, and then it'll have the number 12 because that's what got returned. All right, so we're done with that statement in triangle info. So we go to the next one and we do print area is. Okay, and then over here for area, we're going to put a new frame. And the current values for A, B, and C, which are 4, 4, and 4, will get copied in for S1, S2, and S3. So this is 4, 4, and 4. Okay. And so those will get copied in, and I do S equals 1/2 times perimeter. So I've got to call perimeter. So when I call perimeter, the current values of 4, 4, and 4 get passed in. So I have a call to perimeter. It adds those up, gets 12, returns the 12. Where does it return it to? Well, it returns it to the area. Okay, so this value now is 12 because it gets returned for that. So half of 12 is 6. The value of 6 gets stored in S. So this is 6. Okay. And then it's going to call math square root, and it's going to do 6 times 6 minus 4 times 6 minus 4 times 6 minus 4. So it'll get the square root of 48. Let me see what that is. Square root of 48 is around 6.93. 6.928, blah, 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 blah. Okay, and so that value, as far out as within as many decimal places as it can get, will be returned for this area, for this A value. Okay, it will return now that's 6.928 blah blah blah, close to 6.93. Where will it return it to? Well, that comes off the top of the stack. It gets returned to triangle info. So it gets returned to where it had called that. Okay. And so now it's going to pass the 6.93-ish number into the print. Okay, the print will take care of it. That's the last statement. So it's going to exit triangle info. And it'll be back to the main program. Okay, it'll be right at the end of this statement. There's nothing else to do. And so this will go, and there's nothing else there, so it knows it's done, and the program has run completely. Okay, so that's how it takes care of the stack. So let's go ahead and run this. Okay, so when we run this, notice what we get. Okay, it printed the greeting message, the 2, 2, and 2. Okay, let me find my little guys. Okay, and when it was in there, it printed the 12 for the, sorry, the 6 for the perimeter. 6 for the perimeter. I've got the wrong one. 6 for that perimeter, and then the 1.732 here for the area. That was for the first set of calls, and then the second set of calls. Okay, we had a perimeter of 12, and then an area of around 6.93. So those were our second set of calls. All right. One thing that I wanted to do was, like, let's say that there is some kind of a problem and our program crashes. So let's say this happened before. Last time I gave invalid sides for the sides of a triangle. It wasn't a real triangle, and so when I was trying to print the area, it just crashed. So let's do that. So let's say we have 1, 2, and let's make this 5. Okay. Those aren't valid sides of a triangle, and so when you try to find the area of the triangle, it's going to crash. So let's think about what happens. When is the first time it's actually going to try to find the area? Okay, so think about what happened. We will have called main. Okay, let me give some new numbers though. I don't have a new piece of paper. So let's say we called it with 1, 2, and 5. Okay, it's going to display the greeting. Nothing bad's going to happen there. So it's going to do greeting. So it's going to do the greeting. The greeting will be fine. It'll return from that. And then it'll do triangle info. Okay, so triangle info. I'm going to have to reuse these. It's going to be 1, 2, and 5. Okay. So the first thing it'll do is print the 1, 2, 5, do perimeter is. So when it does perimeter, it'll be 1, 2, 5. It'll add up 1 plus 2 plus 5. That's fine. 1 plus 2 plus 5 is okay. That's 8. It'll return the 8. It'll come back here. And then it'll call area. So it'll call area. These values will be 1 and 2 and 5. There won't be anything here yet, and there won't be anything here yet. Okay. It'll call perimeter. Perimeters 1, 2, and 5. It'll return the value of 8. Okay, and so S will be half of 8, which is 4. And then when it gets down here to try to do A, it'll try to do the square root of 4 times 4 minus 1 times 4 minus 2 times 4 minus 5. Well, 4 minus 5 is a negative number, and we can't take the square root of a negative. And so at this point, when it's trying to do this square root computation, it's going to have an error. Okay, so that's where it should be when I run it. So let's look at this. We're going to run the module. We're going to save it. Okay, and we crash. What happened? Okay, if we go to the bottom of this, it'll say value error. There's a math domain error. Okay, the domain of the square root function is positive real, well, non-negative real numbers. It has to be 0 or greater. And we gave it a negative number. That's not in the domain. So let's look at what's called the traceback. So here it will show us this is the top of our stack. So this happened in line 15 of area. Okay, let me move this one down. Okay, so line 15 of area. So here was our top one. Okay, and where did that get called from? Well, that got called in line 22 of triangle info. So if we take that off, yep, that got called from triangle info. Well, where did this get called from? Well, if I go back one more, that got called, it says in module. That's the main program. So if we take this off, sure enough, that was the main program. Okay, and so if you follow along, this right here is the bottom of our stack. This is the next frame on the stack, the next frame on the stack. You can follow those through and see which function called which function, which called which function. So, and it'll just match up exactly with the stack trace that we did ourselves. Okay, so that is a handy, you know, you don't have to draw little papers for yourself every time, because the error message there is being nice to you, and it's keeping track of all of your frames and all of your stack, and it'll tell you what called what. Now, it's not telling you all of the values of all the variables, but at least you know what call happened, and you can say, okay, well, I've got to go to my main program to line 34 and figure out what the state was at 34. And then it was fine until it got up to line 22 in triangle info. Well, then, and it called that, all right. And then it went to area. And you can kind of see the flow. And so that will help you with your debugging, as you can see where everything was called in the program and exactly what state it was in when it crashed. Okay, so hopefully that helps you understand sort of the flow of the program and how the interpreter is going through and just running things line by line by line, and how it's able to keep track of its own local variables. It just makes one of these little frames, and so every single function can have variables that are named the same thing. It doesn't matter, because it creates a new frame with its own versions of those variables, and then as soon as you return from that function, it gets taken off the stack, and so those variables don't exist anymore. Okay, so hopefully that helps you understand how all of that works, and you should be able to draw your own stack diagrams.